solving logarithmic equations. We will solve these three lovely equations using, for the most part, the same method. And that will be to kind of isolate the logarithm and then to solve from there, either utilizing the definition or an inverse to try to get rid of that log. So in A, let's start by noticing that we want to get x. So we are going to need to get everything away from this x ultimately. That minus 3 we're going to have to get rid of, that natural log, that 3, and that 4. So let's work our way towards it, starting by subtracting 4 from both sides, and we will have 3 natural log of x minus 3 equals 1. And if we try to continue isolating x even more, the next thing we would get rid of is this 3 by dividing. And now we have natural log of x minus 3 equals 1/3. At this point, we need to get rid of that natural log. Now, if you can remember, the inverse of logs are exponents, or exponentials. And in this case, this is log base e, natural log. So we could take e on both sides. And that would kind of cancel this out, because remember, that's log base e. So e and log base e would cancel, leaving us with x minus 3 equals e to the 1/3. That's our power there. Now the last thing to do to get x would be to add 3. Now you can get an approximate answer, but this is an exact answer. E to the 1/3 plus 3 is our exact answer. If you were to evaluate this with your calculator, taking that cubed root essentially of e and adding 3, you get about 4.396. So either answer. If they ask for a rounded answer, I would provide the decimal. If it's an exact answer, you would need something with e in it, especially when it's natural log. Problem B, same idea, different base. Let's get that log by itself. So we're going to move the 5 to log base 3 of x plus 4 equals 2. And now we're trying to get to x still. Let's get rid of this 2. So log base 3 of x plus 4 now equals 1. At this point, you could take both sides to the base of 3, because that's the inverse of the log base 3, an exponent with 3, or like this, or you can utilize your definition of a log, and I think that would be the easiest route here. We're going to get a nice answer, I can tell. 3 is our base, 1 is our power, because remember logs are powers, so we have 3 to the first power equals x plus 4. Again, 3 is our base, 1 is our power, and this is what it equals, x plus 4. Now 3 to the 1 is just 3, so let's just do a quick subtraction, and we'll find that x equals -1. Now again, we need to kind of double check this answer, make sure it's reasonable for this problem and not extraneous. If you plug in -1 here for x, -1 plus 4 is +3, and that is fine and dandy. Log of 3, when you're in base 3, is 1, times 2 is 1, plus 5 is 7. Look, we just checked the problem. Correct. X is -1. C is the most complicated looking of all these problems, and again, we're going to utilize our properties of logs, so hopefully you've got those memorized by now. When we have a log of a difference here, we're going to condense that into one log, same base, of the quotient, x plus 4 and 2x plus 1. Now, right now this is equal to log base 17 of 10. Notice that both sides have log base 17. It would make sense, equality-wise, that if you have log base 17 of this equals log base 17 of that, the this and the that have to be the same. So essentially, we're just going to focus now on x plus 4 over 2x plus 1, making sure that that equals 10, because we've got log base 17 on both sides already that's equal. And when I see fractions, I think about cross multiplication. So I'm going to cross multiply here, getting 20x plus 10 equals x plus 4. And now we're just going to solve for x. 19x equals -6, and in this case, x equals -6/19. Once again, we're going to have to double check, make sure we don't get any negative answer by plugging this in. And we don't. -6/19 plus 4 is 3 something. 3 and 13/19 positive. And 2 times that fraction plus 1 is still not going to give us a negative result. So this is our answer. It is not extraneous.